Hey, first. It does matter. It matters who's first. Welcome. Thanks for being the first person in the chat. X Metrics. How's everyone doing tonight? What's up, M. Dixon? Let's get the sound right. I didn't move my lights back down. I changed my camera from the automatic mode because I noticed in the videos that it kept autofocusing, so I changed it to manual, manual mode. And I got to change the exposure just a little bit. It's just a little bit dark. But how's everyone doing tonight on this exciting Python bootcamp night? Yeah, these softboxes are they're good. I think maybe I'm just used to seeing a little bit brighter. Maybe my screen's actually kind of dark. I might make them a bit brighter. I might just get the desk ones. These are kind of big, and I might use these for like my YouTube videos and stuff instead, because they're kind of portable. But they're cheap. I might get the little ones on the desk that I can control with the Stream Deck. Just so I can turn them on and off. These are hard to turn on and off because I gotta reach up kind of high. But tonight's gonna be fun. Excuse me. Tonight we are working on algorithms. Intro to algorithms. Let's see here. Man, we've done a lot. We've done, what is this? We're wrapping up week 4 now. Anyone who's brand new here, we're wrapping up week 4. We've learned a little bit about, basic programming concepts. We learned about Python 3 and editors and IDEs and how to get stuff installed. We learned about input, output, variables, and data types like strings and integers and floats and booleans. We learned about data structures so you can manage that stuff easier. So with lists and dictionaries and arrays and tuples, or tuples, or however you want to say it. We learned about operators and expressions. We learned how we can compare values, make decisions. Learn about arithmetic operators, do a little bit of math. We learned about conditionals and control flow. We learned how to take that stuff from above, use these operators and expressions to go ahead and start making some decisions in our applications. So that's what we learned on Monday. But tonight we are going to do an introduction to algorithms. So we're taking this at a nice good pace. This isn't going to be the deep dive all the way into algorithms. You can see here we have this intro to algorithms, but then in a few weeks we have algorithms part 2, and we have an algorithms part 3. So anyone who knows stuff about algorithms, we're not going crazy deep tonight. We haven't even learned. We still haven't even learned. Haven't had a official course on loops yet or functions. So tonight, again, is just the introduction to algorithms, how to approach solving them. We will solve problems tonight, but don't get all, if you were looking for things like bubble sorts and merge sorts and things like that, and shortest distance algorithms, those are coming. They're definitely coming, but they will not be coming tonight. So just want to set some expectations. What's up, FMOMO? Let's see, code a front end for it. Hold on, softbox for the win. They put it. Yeah, I mean, I could do that. I definitely could do the ones that work with the Stream Deck. We could definitely do some. I actually was watching someone last night do some Twitch integrations with their Stream Deck, but it looked harder than I thought it was going to be. I thought it would be a little bit easier to make your own. I guess that's why there's not that many plugins actually out there for the Stream Deck, but the ones that are there are pretty good. Does everything that I needed to do. Hey, Oyaves, hello, welcome to the stream. But cool, tonight's let's pull up the slides. We do have some slides tonight. We have a very small amount of slides, because again, this is the intro, and tonight we're going to be a little more hands-on with this stuff. Also, announcement for anyone who wasn't on yesterday on the DevOps bootcamp. The big announcement is that on Sunday we will be having the DevOps bootcamp on Sunday, but it is Super Bowl Sunday here in the US for everyone in the US. So we're streaming early on Sunday. We're actually streaming at noon Eastern time, so 12 p.m. Eastern time. I'll send it out a bunch of places starting tomorrow, but we're streaming noon Eastern time on Sunday, so everyone can have time to spend with their family and friends for the Super Bowl, or just to spend time with your family. So yeah, so that's what we're doing then. So just, I don't want you guys to sign on and realize that like, hey, he's not streaming right now. You should be able to watch the replay if that's your preferred time to watch. Anyone who's not going to be watching the Super Bowl, you should have access to it early in the day. So we should be done about 2:30, 3 p.m. Eastern time. So just hopefully remember on that. Go Chiefs! I'm in on that. Go Chiefs! I would prefer the Chiefs to win, but I'm also, I'm indifferent. Unfortunately, I'm a Redskins fan, just because I grew up right next to the Redskins Stadium. I have to be. I like the Ravens. I was rooting for the Ravens, but wasn't too hurt when they lost. But yeah, so I would like the Chiefs to win, but I'm not going to be. I think it's just going to be I think it's going to be a good Super Bowl purely because the Patriots aren't in it. I think we all are just happy the Patriots aren't in it this year. So cool. So that was the news. What else can we do? What's up, my new brain? How you doing? Go Birds. I mean, hey, whoever wins, it's gonna be fun. It's a good time. Usually, I wonder where I'm gonna go watch the game. No one's invited me over yet. Usually we watch the game with my family. This is usually my brother's birthday time. So usually it falls right around this time. So we usually go over his house and have a little bit of a party. But yeah, I do like to see who people are. I would like to know the overwhelming majority of who people are going for. Yes, the San Diego Padres are in fact playing in the Super Bowl, but they are they're an extra team. They're a standby team, just in case people get sick on either of the other teams. You got to have your extra players. So they are a good team. They didn't do amazing this year, but they're not bad. Lots of Cowboys. There's lots of Cowboys fans everywhere. I mean, there's probably more Cowboys fans in the DMV, right in the hometown of the Redskins. There are probably more Cowboys fans here. There are definitely always more Cowboys fans at the games than Redskins fans. It's pretty crazy. I don't understand it. I don't understand why everyone loves the Cowboys so much, but it's okay. It's all right. We'll give people 2 more minutes. Like I said, tonight's going to be pretty short. This is a true introduction to algorithms tonight. So nice and slow. It'll give you a good opportunity to take some time and just get comfortable getting into problems, reading problems, and all that. So we're not in a rush at all tonight. What's up, Stephen Joe? I'm glad you got me live as well. What's today? So actually, let me see something. What do we have next? So Monday loops is good. Okay. Okay. This is good. This actually, I'm glad I did it this way to give you guys some time to like everyone who's this is your first time following along with something like this. I think this will give you a good, like a solid introductory session before this one, because we're going to pick up a lot of information in between these two things, in between the intro to algorithms and algorithms part 2. It looks like we're going to pick up kind of the final major pieces. Then we're just going to be building stuff. A few more topics. All right, cool. Well, let's go ahead and get started. More time to run through some problems. So, introduction to algorithms tonight. Problem solved. If anyone who's learning how to code has probably been haunted by the word algorithm, has probably heard it so many times that you're gonna have to, get algorithms thrown at you to solve, to be able to get jobs, etc. So we're gonna talk about those things tonight. We're gonna make these a little less scary tonight. Link for slides. It should be. I'll share it. Is it not in the? Should be available in the Google Classroom, but here goes the shareable link. 1 second. Here it comes with a link. Cool. So there goes the link to the slides. Like I said, pretty straightforward tonight. So You saw this in the beginning. One thing I want you to do is focus on the concepts. Really focus on the concepts tonight, especially tonight. Tonight, even though we will be coding a lot, the concepts are what are important. How to solve these problems is important. All right, so what are algorithms? First off, let's start with that. So algorithms are simply a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. There are a bunch of definitions that are all very similar to this. You can Google what are algorithms, and you'll come across a bunch that may make a little more sense to you than this one. But all this is just a set of rules to be able to solve a problem. So there's some other definitions that say basically it is a set of rules that take input and process something to achieve a goal and provide output. And so that's what our goal is tonight. It is simply the steps and the logic to get to an end goal. All right, so we know that all algorithms are a list of instructions, our set of rules to be able to solve a problem. So that means to be able to solve algorithms, you have to be able to solve problems. The goal for the rest of this course is to, yes, learn Python, but to learn how to solve problems, learn how to use the tools that we're learning in Python to solve problems. So how do we solve problems? And this is a very simple list because this is a very basic list of how to solve problems. Obviously, there are tools that you'll always be able to add on to this, but this is kind of a base level of things that we'll all need to solve problems. So the first one is to comprehend. And I put comprehend here instead of read. Originally I had read here, but that's not quite everything we need. So algorithms will always be presented to you as a problem, whether or not it's a practice problem to solve on one of the websites that we're going to use tonight, or if it's you need to create an algorithm to solve a business issue. Working for a company, they need a specific problem solved, and you have to write an algorithm to solve that. It will be outlined in a number of different ways with words. So one, understand. You need to read. Reading is the first part of comprehension for these problems. You need to read. Make sure you read all of the problem. Read it a few times if you have to. Read it 2 or 3 times. Then take the time to understand or do your best to understand what it is asking. So don't only read the problem, but take the time to understand what the problem is and what the proposed solution is, and start to understand the delta between the area you're at and the place that you're trying to go to. So really understanding the problem and what the outcome is intended to be through these algorithms is very, very, very important. And again, when you see them, when we go through and practice reading them and going through those, it'll be easier to figure out how to truly comprehend these things. So 2, how do you solve a problem? First, you comprehend it, then you break it down. So this is a general rule about not even just programming algorithms or programming problems. Once you can comprehend a problem, you break it down into digestible pieces so that you can understand the actions that you need to take. So take this problem, using maybe in the beginning, you may break down this problem way different than I do in the beginning, because again, we're going to all take our tools. We're going to think back to the tools that we have, that we've learned from Python, the tools that we know that we have available to us, and you're kind of going to naturally chunk out the work that way. You're gonna say, oh, okay, it looks like here it seems like I'm going to need to use a variable. It looks like here I'm going to need to use some type of loop to iterate over things. It seems like I'm collecting some data here, so maybe I want to use a list. But again, if you aren't familiar with some of these tools that you have available to you, if you're not familiar with a method or a function that is available to you, you may break it down in a different way. And that is okay. That is absolutely okay. But break the problem down into consumable pieces that you can solve. And so again, comprehend it first. Now, once you have some comprehension of it, go ahead and break it down into the pieces that you can attack and that you can solve. All right. Pseudo code. Never know if this is 1 word or 2 words. I know it's 1 word. I know it can be 1 word, but I often see it as 2 words as well. So I just made it 1 word, but made code lowercase so that I get both right. So I'm not really wrong either way here. Or I'm double wrong. Who knows? But pseudocode. What is pseudocode? So now that you've comprehended the problem, you've taken your time, you've read the problem, you've truly understood what the issue is and what the solution might be, or what's being asked of you. And now you've broken down the problem, you've taken it, you know what your issues are, you know what pieces you can start to attack. Now you can write some pseudocode. So you may not always know exactly how to write this via the language that you're using, or you may be trying to express your solution to someone else. But pseudocode is a quick way to write code like functionality and logic to base your code off of. So we're going to see an example of what this looks like. Actually, take a look at it right now. But pseudocode is not actual code. Generally, for the most part, there's no real structure behind it. There are some pseudocode frameworks that people try to use, but for the most part, pseudocode is simply some people take their pseudocode as actually writing out the words like I must like create a variable for X that holds this value. And the next line will be now iterate through this, just like we talked about before, how we're going to break down the problem. Your pseudocode can be just that. A lot of people, it's easier to draw, and maybe we'll do some draw.io to show some pseudocode. And again, it's going to look different also depending on the language you're writing with, because some people like to add a lot of that syntax into their pseudocode. But let's take a look. Oh, this looks good. I like this. Open image in new tab. All right, so take a look at this. And while it looks like the structure of code, kinda. And actually this is like some more advanced pseudocode than you probably need to use. I'm not sure what language this is, but you don't know about for each loops yet, but it looks like they're just kind of stating that we're kind of going to run a for each, for these different things. Then we're going to mark P as visited. This isn't code here, but we're going to mark P as visited, and then we're going to change some things here. And we're going to say if, size of neighbor points, like we're almost writing it out as plain English. We're writing the logic and the structure out as plain English while ignoring the syntax of the language. And again, this can be valuable for a number of reasons. Let me see if I can find a better example. Here goes a good one as well. This is a syntax that you'll see a lot. I do not write it like this, but yeah, this is not any language. This is just an example of like they're assigning values basically instead of using equal signs with these arrows. But yeah, you can write your own pseudocode to meet your own needs. It's not super important that you memorize any type of like you don't have to use this syntax, this nomenclature for things. But yeah, we're going to write out some pseudocode with the stuff that we're going to do tonight so that we can understand that as well. Part of the reason I'm learning Python is to do algorithms in Python. Awesome. That's great. So we're definitely gonna start learning that now. You'll have all the tools available to you, and we'll have practiced them enough for you to be pretty darn good, I think, by just in another few weeks, to be honest. But yeah, pseudocode is, again, it's a powerful tool to kind of help you get the structure of your code down without actually having to worry about the syntax. So like all the other stuff looks like a bunch of characters and whatnot. And you can see here, let me go back to that image. Let's see, open image in a new tab, make this a little bit bigger. And you can see here, this person is using plain English to you can see it kind of looks like code, but says set total to 0. You know how to do something like that. So it's saying like basically set a variable total equal to 0, and then get list of numbers, loop through each number in the list and add each number to total, end loop. So this is, again, plain English. This is not real code, but a version of code that can help you structure and figure out your logic for your code. And this, again, I would always, in the beginning, I would always start with something like this. While you're learning, pseudocode is pretty cool and will help you out a lot. All right, so after you do your pseudocode, go ahead and convert that pseudocode to code. Once you get your pseudocode down on paper and you're like, okay, this logic feels nice. Everything feels good about this. I believe that this logic solves the problem. Now you can start converting your pseudocode into your actual code. Writing the functions that are needed, writing the loops, the logic, getting your variables in place, but writing the actual Python code, taking your pseudocode as reference and applying that logic into real code. So that is what you would do next. And then the last thing you're going to do is you're going to optimize. So the first iteration of your code, I think the saying kind of goes like, make it work, make it fast, make it right. So that's usually the steps you want to take when you're solving a problem or doing work, to be honest. The first thing you want to do is put a priority on making it work. And then after you make it work, the next priority you want is to make it fast. And so make it, work quickly, because making it work and making it work quickly can be two completely different things. And then making it right is the last piece. So making it syntactically correct or making it the way that it's supposed to be ideally as the last piece. Code generally doesn't come out of your head like that. So that's the order I think you should take. That's the order I like to take, and especially when you're trying to solve these problems. Again, after you make it work, it's kind of easy to all right, take a step back, look at it, see where you can optimize, see where you can refactor your code to make it better, and to make it right. Again, I've written so many of these things. Remember, I showed you when we did FizzBuzz, your first iteration of FizzBuzz could have been 100 print statements. Again, reasonable solution, like, from the question that was presented to you, from the word problem that was presented to you, and what the intended output was, that would have solved the problem. Again, we made it work, and that would have been number one. Sure, I guess it's kind of fast, I guess, but it's definitely not right. And so just being able to step back and say, hey, there's easier ways, there's better ways, there's ways that are easier to read for other developers, there's ways that are easier for me to read as a developer when I get back to this code later. All that stuff is important. So optimize last. So let's run over all those again. Comprehend first. Make sure you understand what's going on. Read. Make sure you understand what is being asked of you first. And again, sometimes that can be confusing. Like, don't sweat it if you don't understand, but do your best to try to understand. Then break it down. Break it down into pieces that you can that you can tackle, and then use pseudocode to tackle those pieces. To write structural code. To write what is it called? Like logical, non-syntactical code. And then go ahead and write your code. Use that as a basis to write your actual code. And then after you've written your code, if you have time, go ahead and optimize and make better. But cool, now we're gonna practice. We're gonna spend the rest of the time practicing. Tonight, we're actually, the last 20 minutes, we're gonna hop onto exorcism, but we're gonna start off much simpler, actually. So we're gonna go to practicepython.org. And I remember going to this stuff a long time ago, and I remember these being really good because the beginner exercises are, I think, actually beginner exercises. Whereas if you go to other sites, I think the beginner problems aren't quite beginner problems. So it's easy. It's hard to write beginner problems once you've learned the language. You just forget what it took to get you to where you are now sometimes. So yeah, we're going to hop into these. So practicepython.org. I will head over there. You can either head over there now or just bookmark it, because again, I think there are some good practice problems on here that we can start with. And again, you don't have to. I know some people who will get on a site like this and get stuck and stay on the site forever. No, I'm gonna give you way more resources for you to practice problems. Grab problems from all over. Also, do not stop on there's a lot of value in attempting to solve a problem and thinking about a problem. It's okay to not be able to solve it in a reasonable amount of time. I think sometimes you can time box yourself, spend time working on it, then go look for the solution. You'll learn a lot from trying to come to a solution, genuinely trying on your own to come to a solution. Even if you can't get there, taking a look at a solution and figuring out, again, that delta, figuring out what is in this solution, how much more would it have taken you to get here? You can uncover some concepts during that process as well. So yeah, there we go. Legend says senior devs Google basic stuff too. Absolutely, 2,000%. The simple stuff is what you have to Google. That's what the crazy part is. Like, the simple stuff is what you have to Google for sure. it gets difficult to remember stuff, especially again nowadays. Nowadays, you generally aren't working with one core technology or language like consistently for a very, very, very long time. So like it gets harder and harder to not have to Google that stuff. But that's very true. Yeah, once you get good at Google Foo, I mean, you can do just about anything. Like I definitely, I know a little bit of Ruby. I was helping somebody out with a project, a pretty big like Ruby application that they had, and like I was able to seriously contribute to that just because Google Foo. I knew the tools that I could use in programming to solve the stuff that they wanted, and I was able to help out just purely because of what I got off of Google, and again, just kind of being able to decipher kind of how things run, how things work. But sure, and principal dev constantly Google stuff, absolutely. All right, so let's start with the very first one. We can skip around, but let's start with the first one. I like here how they have these little chili peppers to tell you which ones are getting harder. But let's go ahead and read through these problems. Maybe we can try some pseudocode. I don't know if pseudocode is going to be valuable for these, but we can try. But yeah, so let's read again. Let's do the first piece. Let's comprehend what is being asked of us and what the input is and what the output is. So calibrating these exercises is going to be challenging. Okay, so that's not the problem. All right. So, another reason why I like this practicepython.org one is I like the sites that give you both the question and the answer. I like having the solution immediately available to you because again, there is value in working on a problem, trying a problem, but there's a lot of value in taking a look at the solution later on and kind of being able to walk yourself to how they got there or how you would get there. So this is a good site for that. So our first exercise, and we're going to copy and paste this into our code so we don't have to keep coming back to it, but let's read it first. Create a program that asks the user to enter their name and their age. Print out a message addressed to them that tells them the year that they will turn 100 years old. Okay. We're not going to read the extras yet. Let's just start there. I really like this as the first problem. So let's break it down a little bit. Let's read it again. Make sure we understand what's being asked of us. Create a program that asks the user. So we ask is a key word. We know how to ask the user for things. Ask the user to enter their name and their age. So it sounds like we're going to be asking them for two things. So their name and their age. Okay. We're going to print out a message addressed to them that tells them the year they will turn 100 years old. So that's the output. The output is the year that they will turn 100 years old. So we're gonna take in the name and the age, and we're gonna kick back out to them the year that they're gonna be 100 years old. Okay. Interesting. Very interesting problem. This is a very good one. I like this. All right, let's hop into here. I don't want ZSH tonight or any other night. Documents. What are we doing? Mastermind, streams, Python. What's in here? All right, let's make a new conditional execution. All right, so let's okay there, Al. I'm trying to look at my keyboard. I'm practicing. I'm getting better, but slowly. CD algorithms. All right. Hey, what's that? X cacao. Like not a cocoa bean, but a cacao bean. Hello, welcome. Thank you. Appreciate the follow. Print, you will die before you are 100. Sorry. I like that. That's solving problems. I know for sure you are principal dev now because that's how you solve problems for sure. Hey, Faye, Retro Renegade. Someone just followed and it didn't update yet. So I don't know who that was, but welcome. I'll give you a shout out whenever it updates here and I can say hi to you. All right, here we go. Let's go ahead and paste this in. Let's make our file. So we're gonna call this turn 100. Wow. Turn 100.py. All right, so let's paste in this so we can read it. Gross. All right, what do we do? Trophy. All right. Create a program to ask the user for this. So let's break it down. Let's write a little bit of pseudocode. Actually, let's break it down first. We want to do one. Create a program that asks the user. Ask user. This is how I break it down. Ask user to enter name and age. And then so maybe I will break that down even further, but let's do that first. That's the first part I will break it down to. Print out a message addressed to them that tells them the year that they will turn 100 years old. So print message, again, we need to really comprehend what's being asked. It says message addressed to them. So we know we need their name, so we can use that. Addressed to user. With address to user with age they will turn 100. So cool. So when you break it down first, it sounds like you only have 2 things to do. Now there are more things to do in here, and so let's break these down even more. So yes, we broke the original problem down, but I don't think it's broken down enough. We need to break it down a little bit more. So let's do that. Check out the sickest keyboard builds. Oh yeah. I watch Teha Types. I watch Teha Types all the time. That's usually my go-to. I usually watch his streams like after the streams when I'm working on some other stuff. Yeah, Teha Types is it's a pretty chill stream. I love it. Okay, you're right. Year, not age. That was dumb. Because everyone will turn. We should have left it there and made the program super easy for us. All right, so let's break this down a little bit more. I want to break this down a little bit more. This has 2 parts really. So we have to ask the user to enter name and age. So ask user to enter name, and then 1B, I would say is ask user to enter age. And this is kind of becoming something like pseudocode. We could turn this into a little bit better pseudocode when we're done, but this is kind of how pseudocode is. So we'll break this down into 2A. We can say print message addressed to the user with the year they will turn 100. So we can start off with print message addressed to user. We can say 2B. We can say we'll need to calculate year. Calculate year user will turn 100. And so maybe we'll flip that around. Maybe that'll be whoa, undo. B, X that up. B, what just happened? Oh, undo. We'll make this B. So here we'll need to calculate the year user will turn 100, and then we'll print a message addressed to user with the year we calculated. All right, so now we can break it down farther than this, but we're going to use this to break it down a little bit more into pseudocode. Addressed to the user with the year. The year user will turn 100. All right, cool. Why are we not using VS Code no more? So we can use VS Code again. That's why I wanted to talk about the concepts of the text editor. This is it does whatever. It doesn't really matter what text editor you use, because again, we're just using that to type in things. I just use Vim because Vim is just the text editor that I prefer. We can absolutely use VS Code. Your colors and stuff will be different, but aside from that, there's going to be no increased functionality out of me showing this to you with VS Code. The only thing that might, there's going to be no. I don't think we need to use it, but I can use it. If you prefer me to use it, I will absolutely use it. But I've been a Vim user for a while now, so cool. All right, so we kind of have basically right here, kind of our breakdown of a pretty simple problem. It might not sound simple, but it's a pretty simple problem, and we kind of have a breakdown. So let's turn this a little bit deeper into pseudocode. Let's take this and let's turn this into some type of pseudocode. So we need to ask a user for their name and age. Again, your pseudocode there's no real rules to pseudocode. So I would do something like this in my pseudocode. I know I need to ask my user for a name, and I know how to get users. I know how to get a user's input. I know to ask a user for something like that. And I know what to do to make sure I can use that data. So I would say ask user for input, for name, and then I might put something like this, like assign to name variable. I might say something like this. Pro programmers use Notepad. Nope. Not chisels and clay. I love it. So I might say something like this: ask user for input for name and assign that to name variable. And then I might say again, ask user. Maybe I'll take out for input. Ask user input for age. Assign to age variable. And sometimes you don't even need to get this kind of granular in pseudocode, but we're gonna start here. Maybe I also put up here, I'll put a pseudo code. So you know this is my pseudocode. I'll break this down a little more. All right, so ask the user for name, assign a name variable. Ask user input for age, assign to age variable. All right, so that gives us 1 and 2. So this pseudocode is going to be a little bit deeper. So I need to calculate the year a user will turn 100. So this is where your thinking really happens. After you've broken it down and you're kind of figuring out how to solve it right in the pseudocode, how can we do that? Like, how can we use the information that we have available to us to calculate the year in which a user will turn 100? So what information do we have that we could use? We have the user's name and we have the user's age. Excellent. So we have the user's age. So we got something to work off here. There's a couple ways you can do this. We also, not only do we know what the user's age is, so we can determine how far, using the user's age, we can determine how far away from 100 they are, how many more years it's going to be until they're 100. So that's what we need to figure out. So I would say the next thing that we do is we need to calculate, we need to subtract actually, user's age from 100. And so you could put more information in there if you wanted to make it easier for you to know why. But again, if I take your age and I know we want to know how many more years it's going to be until you're 100 years old, all I have to do is subtract your age from 100, and I'll get that value. So for me, I'm 29. So I subtract that from 100, and I will get 71. And so that's how many more years it'll take for me to be 100 years old. So that's the next piece of our logic. This is our pseudocode. Subtract user's age from 100, and then maybe we want to assign that to a variable. And let's say assign to variable for assign to years left to 100 variable. And again, I'm just throwing stuff out here. This is, again, pseudocode. We are just messing around. All right, so this is gonna be the calculation that tells me how many more years it's gonna be until I'm 100. Now that we know how many more years it's gonna be, how do we know? We know the amount of years it's gonna be until this person is 100. But how do we know what year that is? Well, don't we know what year it is currently? Yes, we do. I hope you do. I hope you know that it is now 2020. So what you can do is you can add years. Well, let me autocomplete. Yeah, it will. Thank you, Vim. We'll add years left to 100 to the current year. And the current year is 2020. And then we will build a print statement which has the user's name and year they will turn 100. All right. Excellent. So, Exacal, how do you know the current year? Will it be hard coded? Yeah. So yes, it'll be hard coded. We could, maybe that's something we can do before we hit the extras, is have them also pass in the year. If you want it to be able to work for more than the current moment. So yeah, you can absolutely pass in the year, but right now it wants to know what year they'll turn 100. We know what year it is now. We're about to run the program now, so we'll deal with that. And then we can actually have the user pass in the year, the current year, just to make it a little more future-proof, per se. But yeah, you can also grab, absolutely, easy goodness. You can absolutely grab it from the computer clock as well. Yeah, maybe we'll do that too. We know how to take input, so maybe we'll grab it from the computer's clock. I think that might be a little more fun. Maybe after we do the extras. I think that's a really great idea. Cool. But we will go ahead, in this example, we'll go ahead and we'll hard code it in. How do you know if they had their birthday or not? You don't. This algorithm doesn't, we're only going to operate off of what it's telling us. Yes, we don't know if they have their birthday or not. For someone, like most people, actually, this would end up actually being false for. Right now, it would be 1 year off. Because of the month thing, but absolutely. So I love these questions. Actually, let me save this to the to Google Keep. Maybe we can add that as, like we did last time. Maybe we can add that as a homework assignment in the repo to go ahead and try to be able to do that. Like, how do you figure out, determine what their birthday is to know which year? That would be really good. It would add not a significant amount of complexity, but yeah, it would add a little bit of complexity to this. I think it would be fun. These are good. You guys are making these great, asking the right questions. I like how inquisitive everyone is. So let's start with this. So let's now that we have this pseudocode, let's turn this pseudocode. So we have the breakdown here. We turn the breakdown into pseudocode, and now let's turn this pseudocode into actual code. So I'm gonna have to comment all this stuff out, but I'll leave it there so it's not all gray. All right. So first thing, ask the user input for name. So we need a variable here, assign it to name variable. We can call this variable whatever we want, but obviously I'm gonna call it name. Hey, what's that, Karis? Hello, Karis, welcome. Thank you for the follow. Whoever followed before, was that Richard DC7? Welcome. Thank you for the follow. But cool. So we do name, and we know how do we grab input. We're harping back to all the things we learned. We're putting all the things together. We do input. We call the input function, and we say, give them a little message, and we say, hello, sir or madam. What is your name? Not what, no, what is your name? I like that. But what is your name? Question mark, colon, there we go, space. All right. So this is how we're going to go ahead and get some input here. Hello, sir, madam. I don't know if that's how you spell it, madam, but what is your name? And that is how we're going to do this first part. So we turned our first bit of pseudocode into code, into actual code. And let's go age. So we said we want to check age, we'll make an age variable, and we'll do this again. We'll say input, and we will say also, comma, if you wouldn't mind, what is your age? Question mark, colon, space. Give a little nice formatting. Oh, okay, just 1D. All right, cool with that. All right, hello, sir or madame. Well, what is your name? Also, if you wouldn't mind, what is your age? All right, so we got that. This will allow us to capture both of these things. So ask the user for name, assign it to variable name. We did that. Ask the user for age, we assigned it to the variable age. Excellent. So we can test. Let's actually just test that piece out to make sure we're doing that. Let's test that out. So just to make sure we're doing it right, let's go ahead and let's print name and then age. And obviously we got to do a little commenting. What do we do here? We do down to here. All right. So to run this, we're gonna do Python 3 turn100.py, and it's gonna ask for my name. I'm gonna type in my name is Timmy, and my age is gonna be 56. And you can see here, it prints out Timmy and it prints out 56. So far we've confirmed that we can take in a name, we got take an input for name and take an input for age. The algorithm that we've been asked, that's exactly what they want us to do. Ask the user to enter their name and their age, and we did that, and we're able to capture that information. Great. We're doing good so far. Does anyone have any questions so far? Feel free to ask any question you want so far. Mom told me never to ask Madame for her ages. That's true. That's true. And we could also address that in our code as well, but we're not gonna do that right now. Hey, Retro Renegade. Hello, hello. All right. What was the key combo for the multi-line insert? Yes. This one, the multi-line insert, is really, really annoying in Vim. I'm still trying to get it down to muscle memory. So the way that you do it in Vim is from normal mode, you hit Control V. So V is visual mode. Control V. I don't know what the control modifier is, but it only highlights the first character or where your cursor is. So hit Control V, and then hit your arrows to select how many lines you want. So just go up or down to select all the lines that you want. Then you hit Shift I to go into insert mode. It'll shoot back up to the first line you were on. You type in whatever things you want to type in, and then you hit escape, and it will apply it to all the lines that were visually selected. Very, very annoying. But I've seen people do it really fast, and maybe there's a faster way. I think people use some people use like Nerd Tree Commenter to do it, but I haven't learned how to use Nerd Tree commenting yet. So yeah, the learning curve always a little bit high. To make this more accurate, can we change the input question for age and ask how old you would turn this year? You guys are solving problems. That is the perfect, man. That is good. I love that. You can get paid for that. You can get paid for that right there. That's some hot fire. Yes, I love it. I love it. Also, if you wouldn't mind, what age will you be turning this year? I like that a lot. Okay, that makes it so now we don't have to do any more handling. We don't care about the birthday. You solved all of our problems. Okay, that's good stuff. Also, if you wouldn't mind, what age will you be turning this year? Okay, so we've already, let's run it just to make sure, that all we did was add something to a string, but let's make sure it still works. And we want to see it ask us the proper question. So name, let's go with Kim. And what age will Kim be turning this year? Always 25. Yeah, there we go. Kim, 25. Thank you very much for that excellent advice right there. All right, cool. Let's scroll down. Let's go ahead and address the rest of our pseudocode. Go ahead and delete this line. All right, so we did this. And actually, let's leave it like this. So ask the user for input for their name, ask the user for input for age. Now, subtract the user's age from 100, assign it to years left to 100 variable. Now, I don't really want to write that long variable, but I'm going to do it anyway because it's descriptive. It's descriptive, but just so when someone goes and looks at it, they'll know what it is. So to do this, I want to subtract the user's age from 100. So we're going to do 100 minus what's the user's age. We know that the user's age was given during input, and so we can use that variable and we can type in age here. So this should give us the value of how many more years it's going to be until this person is 100. So let's go ahead and see if we did this part right. And let's go ahead and print out that. Whoa, why'd you do that to me, Vim? That wasn't a good autocomplete there at all. Yeah, there we go. All right, so let's print out our years left to 100. And we run it again. What's my name? Ferris. I'm making an easy number. I'm 20 years old. This should give us 80. Uh-oh. We have run into our first algorithmic problem. So this is something that you will definitely run into things like this when you are trying to solve your algorithms early on. These caveats you'll run into very often. So let's take a look at the error that we got. Looks super scary, but no big deal. Trace back, whatever, you can ignore that line. The file that it happened in tells us the exact line 26. So in line 26, we can go straight to that line. Years 100, this is the actual line itself. It says unsupported operand types S for minus, int, and string. So that's telling me that I have a type mismatch here that I'm trying to, that basically I cannot perform the arithmetic operation subtract between an integer and a string. Now, what have we learned so far in this course that we can use to fix this? The thing that we can learn, that we've learned, is that we have two different types here that don't interact well. We do know that, that interact well. We know that we're trying to do an arithmetic operation here. So let's go ahead and try to, we have an integer and a string. We know that integers are whole numbers, and that sounds like what we want to get out of this. I think we want to get a whole number in years to the place that we're trying to go. So let's typecast this to something else. So remember, we talked about input. The input function by default, it takes in a string. It returns a string. So we can do this a couple places. We could actually typecast here. And we could actually put this around the entire thing. Or we can do it down here. So I'm actually going to put it here just in case. I actually don't know if we are going to do anything later with it, but I'm just going to put it here. And actually, I think I can use an eval here as well. But I'm going to put a str here. I mean, not str, int. I want to convert it to an integer, not a string. I'm going to convert it here just in case we want to use this age again, so we don't have to typecast it again. So if I put this integer function around it, this int function, it will cast the string to a type to a type integer. It'll do its best to cast it to a type integer. So we're not doing any error handling here. We're not saying, hey, what happens if the user doesn't put in an integer? It'll just fail. It'll just be broken. We hope that someone puts in the right thing, which is their age. So we're going to typecast age, the string age, to an integer. So let's go ahead and see what our output is now. We are still Ferris, and we are still, we'll be turning 20 this year. And we do, in fact, get 80. So it'll be 80 more years until we are 100. That math seems right to me. Let's pass in a little bit more. Let's try Stacy. Stacy will be turning 50 this year. So we should get an even 50 back. So let's do that. So yeah, let's do that. So we'll get an even 50 back. there. So it looks like our math is proper. We're trying to figure out how many more years till we turn 100. If I turn 50 this year, I've got 50 more years till I'm 100. Our math is looking spot on. We are not only algorithmic experts tonight, we are mathematicians as well. So cool. We have figured out how to calculate how many years left until we are 100 years old. So take a look back at our pseudocode. We subtract users 8 from 100. So we just got this done. Then now that we have the amount of years it's going to be until we are 100, we can go ahead and do this part. Add years left to 100 to the current year, which is 2020. So first we'll hard code the year, but then we'll go ahead and we'll do some fancy stuff after this. So let's hard code the year now. So let's see. Let's say, what should we call this variable? Years left to 100, and then year of age 100. I usually don't name my variables like this, but again, I want to be pretty descriptive tonight so everyone knows. Year of age 100 will now be, let's read our pseudocode here. Hey, XOL Grunek, thank you for the follow, welcome. We need to add the years left to 100 to the current year, which is 2020. So we know the current year is 2020, and we can go ahead and add years left to 100. So that's the number that's calculated here. It's going to get added in right here. And so it's going to add it to 2020. So we could also do something like this to make it a little cleaner. There's a million ways we can make it cleaner, but right now we're just solving the problem. We could do like something like current year. If you wanted to make it a little bit, do something like current year equals 2020. And then you can just plug in current year right here. All of these things work. Cool. We'll start here. Let's put a little space, all right, so now we have year of age 100. So let's see if we can get a year when someone is going to be 100. Let's try this out. So let's go ahead and print out year of age 100. Let's save it. And our name is Ralph. And this, I'll be turning 30 this year. So we'll do 30. This should give us 70 years until I am 100 years old. Let's do a little math really quick so that we can kind of preempt this with our own test cases. So what is that? 70 more years from 2020. Very simple math there. 70 plus 20 is 90. So in 2090, I should be 100 years old. So that is what we expect. If I plug in 30, we should get 2090 here. And look at that. We got 2090. We, again, are mathematicians. This is great. This is excellent. We're doing a little bit of math here. So I think we've almost solved all of our pseudocode. We added years left to 100. Now we just need to build a print statement, which has the user's name and the year that they will be returning 100. So let's go ahead and build our final print statement. Maybe we'll use this. And there's a couple of different ways we can do this. I like to use the formatting kind of function here. Let's go ahead and build this out a little bit. And all right, so I'm going to say, hello. Well, I'm going to say your name, even though you already know what your name is. Your name is name. And you won't be 100 until this year, until the year that we have here. So we've gone ahead and we've used the F to format this. So whenever we talked about string interpolation, we talked about evaluating variables inside of strings. So because I have this F at the front and because I have these little curly braces here, and I'm using this very specifically because this is a Python 3 thing, and a lot of people are coming from Python 2 and building strings different ways or using the dot format function. But F strings, but you can just do this little thing here. F strings do allow you to do that, but then you would have to do the comma strings at the end. You do the comma strings at the end. You can't just put them in the string. I'll show you that in a second. But yeah, so let's print this out and see if we get what we want. So I'm gonna use my actual name, and we do 30. And your name is Aaron, and you won't be 100. Maybe I'll put 100 years old. You won't be 100 until 2090. So actually, since we're back in here, I can show you. Like if I just did this, couldn't just stick the variable in there. You would have to do the little thing like this. You have to do the little placeholder thingies, right? Just like a format function, and then give it a. Maybe do something like this. Name, comma. Yeah, I think I'm gonna do something like this for F strings. What happened? Did it work? 100 years old. Oh, whoops. Oh, maybe not. Maybe that's not how you do it. Okay. All right. F strings, Python. I thought that's how you. Am I thinking of Go? I'm thinking of Go. Yes, I am thinking of Go. Let's see. See, we're going back to stuff we already learned, but don't sweat it. This is why we Google. No, I don't want to use formatter. I want to use. Oh, so this was if I used a dot format, I could have done it this way. And oh yeah, you do have to do it this way. You gotta stick them in there. Okay, maybe I read the comment wrong. All right, so we had to write the first time. Put it back in here. Let's do year of age 100. Let's go ahead and delete all this mess at the end. And we have what we need to get going now. So again, Aaron, let's say I'm turning 12. I won't be 100 years old until 2108. So it looks like we're getting different numbers. It feels like our math is right. It looks like our math is right for sure. I really like it. And I think we've solved I would say our first algorithm, but we did FizzBuzz. So I think we've solved it. So there are tons of ways we can change this code. Tons of ways. But again, remember I said, make it work, then make it fast, then make it right. Or maybe it's switched. No. I like that. I like make it work, make it fast, make it right, even though it might be make it work, make it right, make it fast. I'm a speed connoisseur. So I prefer that. Most code isn't right. See, you say make it fast is always last. You know that statement. I know that statement to be mostly true. And obviously in my day-to-day, that is the last thing. Unless it's a true hindrance to the project. But I like speed. I'm a speed stickler. And again, making it right is always a little it's a little abstract for sure, but it's easy to make it fast. All right, cool. So let's delete all this. I'm gonna leave the pseudocode in there so that we can remember what we did here. So before we optimize this, let's go ahead and let's add our extras in here. We got some extra stuff here. Yeah, we have our extra stuff here. So let's go ahead and see if we can add in some of the stuff. So we solved it. We can be very happy that we were able to hop into this and get it done, and we're looking good now. So you could absolutely approach This is how you should approach even whiteboarding problems. I mean, again, there are other tools to pick up to be great at whiteboarding problems, but again, an interviewer will appreciate this breakdown. Like everyone thinks you got to just go ahead and write out code on the whiteboard. Oftentimes, pseudocode is actually enough for whiteboarding interviews. Again, you don't have a text editor. Most of us are used to using the tools and the features that we have available to us and our text editors to autocomplete syntax. That crap's hard to remember. You don't need to remember that. What an interviewer needs to see, are these things: are the way that you think, the way that you break down problems, and writing pseudocode to be able to solve it just might be good enough. But try to do more. Obviously, if you can do this, do it. But like, this is basically what you're going to get into at a lot of whiteboarding interviews. To be 100% honest with you, if it's truly a whiteboard interview, they use whiteboard interviews. Even if they give you a computer or sit you at a computer, or even if you're remote doing some stuff, or live coding interviews, that is what you can focus on trying to do. What we practice up here. So, any questions on that before we get into the extras here? And then we'll get through the extras, take more questions. We'll move on to the next problem. Make it fast. Can wait for code review. Some observation I find early, I suppose. Yeah. I mean, they had me write a program and mine performed better than theirs. Still didn't get hired. See, that was because you didn't get hired, Crafty Gaming, because they were you hurt their ego. Some people have big egos, and you hurt their ego. And I'm sorry to hear that. We appreciate your very quickly performing code, and we would have hired you. I would have hired you. If you can do my job better than me, I appreciate that, and I will just ask you to do all the things that I would not like to do. To be 100% honest with you, it's like I wouldn't do that. Definitely wouldn't do that. That'll be awesome. I always love when people can teach me more, when I can learn from other people. Like that's I bet they use your code. They did. They used your code for sure. They probably felt you were arrogant for being better than them. But who knows? Better than execution speed, much better execution speed. They use poor data structures and a ton of repetition. Yep, it really is like that sometimes. It absolutely. That's why I always tell people, you'd be surprised that like everyone thinks you're going into these interviews and you're talking to people who are super experts. Like that's just that is the adversarial nature in which the interview process creates. It makes it seem like this person on the other end of the table, because they are evaluating you, the assumption is and the feel is that they should know more than you. Most like that's generally the assessment that happens. And it's not true. A lot of times it's not true. It's someone who's just like you, still learning stuff. Yeah, they may have had more years in the industry. They may have seen more things, but they're still learning that needs to be done by everyone. Everything changes so fast. Everything moves so quickly. There's no right answers to a lot of things. You could definitely run into that problem. Okay, let's go ahead and let's hop into these extras. Come on, let's get into the extra credit here. Get some cool stuff going. I don't really know what they're asking for, so maybe I should have read it first because maybe it's too hard and I don't want to do it. But let's see. So extras. Add on to your previous program by asking the user for another number and printing it out. Oh no, I didn't even see. Comprehension, not just reading. Comprehension. I read it, but I didn't really read it. I basically put in a period where there was no period. Let's read the whole thing. Add on to the previous program by asking the user for another number and printing out that many copies of the previous message. And they give us a little hint. That's very interesting. Order of operations exists in Python. That's a good hint. I like that they give you these little bitty hints. All right, let's do that. So let's add to our let's go ahead and add to our pseudocode what we need to do next. Pseudocode, add on to the previous program by asking the user. So maybe we can put it up here. We could do it later on. No, let's make it fun. Let's do it down here. Ask user input for, it just says new number. So I'm gonna say for new number. And I'm gonna say assign to new num variable. All right, so that's the first piece we're gonna do. And then it says, and print out that many copies of the previous message. Okay, so we're gonna take the message that we just printed out and we're gonna print out a bunch of copies of it. So print out new num copies of print statement from 2 steps above. Okay, we got 2 more things in our pseudocode that we can do. So first thing, let's ask the user input for a new number. So let's go ahead and do it afterwards. We can put it at the top. This is kind of your choice. We're just messing around and doing things in order. All these spaces in between don't matter. I was just trying to separate the things that we did, but we'll put 1 space in between those. So let's go ahead and get a new number. New number. New number equals input. Please just give us, hey, iFlubber. Welcome. Thank you for the follow. Welcome to the channel. Please give us a new number. Please again. We want to be kind, you know, we want to be very nice about what we're doing here. We're asking for things, asking for a lot here, actually. So please give us a new number. That's all they say ask for. They don't give us any specifics. They just say ask the user for another number. All right, so we successfully asked for a new number, and we can go ahead and we can print out that new number just to make sure, just so we can be 100% sure that we've captured this new number properly. So let's run it. And again, I'll just do Aaron. I'll do 30. All right, 2090. Please give us a new number. The new number we're gonna give them is 67. And we've run into the same problem that we've run into before. So we get a sweet trace back in this file. If I try to print num, error num, num is not defined. So there's not the same error. What do you guys think that error is? That error is that I typed in num and not new num. That was bad. So you will absolutely make mistakes like that. That's a good reason to use your autocomplete inside of your text editor. I could have absolutely done that, which would have been a little bit safer because you can just have brain fart errors like that. But new num is what we want. And again, my name can be anything, and 45, and give us a new number, 50. We'll give them 50. And it prints out 50. We have been able to successfully get a new input. We already knew we could do that, so we're good there. We can definitely, we've already done that. We've learned how to get input a lot of times. Now, last piece here, we need to print this out. We need to print out a new number copies of the print statement. So first thing we're gonna do is, we know that this needs to be a number. We'll apply the same logic that we had up top, and we'll go ahead and make this an integer right now because we know it needs to be a number. All right, so we'll stop there for a second. If you were coding in Word, you could have it autocorrect your variables. You may have swayed me, Blah7. That is absolutely, put that on the +1 on the reasons why Word is a viable text editor. That's a good idea. I really like that. You will not get banned if you post a link, but it might block it. I still have not reduced its strictness, but you will not get banned. You definitely won't get banned. It's my mission in life to get someone. I mean, I'm gonna be 100% honest with you. That was a good. I'm serious. That's a 4. Like, add that to the pros list. Definitely add that to the pros list of why Word is a viable editor. All right, so let me show you guys something. I know that we did this, but let's hop back into the Python interpreter. We learned that you could do arithmetic operators to numbers, obviously, but we learned that some of them also work with strings. And so we know that this print statement is a string. And what happens when you do an arithmetic operator with the strings? How would we print something the number like a number of times? So you could do a loop. You could set up a loop, like a while loop that we learned. We haven't dived too deep into loops at all, but you could do a loop, and you could use that to print out, loop through and print this thing out over and over again. But there's an easier way. You can apply those arithmetic operators to strings. So this is a string, and we can multiply this actually by a number. So let's say it by 6. And when we do that, we get, this is a string, 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 this is a string. We get it exactly 6 times. So you can multiply, you cannot subtract. You saw earlier that we couldn't subtract an integer and a string, but you can multiply an integer and a string. So now we are going to go and add that same functionality to our code now. I'm gonna go ahead and we got our number from our person, and now let's start to set it up. And we go ahead and we have a print statement here. And what do we need to print? We know we need to print something times this new number, but this print statement that we built up here is not actually like a thing. Well, it is, but it was only valid during this line. So what we could do is we could copy this line. We could copy it if we wanted, and we could print that out 6 times. We could do that, but I think the better option here is to, let's see, escape. Let's go with delete inside parentheses. Let's assign that to a new variable of output equals, and I'll paste. All right. This F thing is only going to work inside of, I think, aren't F strings only going to work inside of that print statement? That's only the format prints, right? Or can I do it here as well? Where are we at? Okay, maybe we can. We'll find out. We'll find out right now. Let's actually put this here. Let's take this back up top. What's this? Windows key, shift up? No. There we go. All right. So here we go. So F strings work here. So now we can print out output instead of that long string. So we can go ahead and print out this variable here, output. And then we can use this. This is one way we could do it. So then we can say, basically we can say output, print output times new num. So we took a new num. That's the new number that was given to us, and we want to multiply our output by that. So we want to print this out new num times. So we'll save that. Whoa, let's run this. So our name is I'm running out of names. Yara. And what age will you be turning this year? I will be turning 6 years old this year. So I won't be 100 until 21/4/2114. New number. Let's go with 67. Actually, let's make it exciting. Let's go 2114 because you asked me for a number, and I can put in whatever number I want. So I'm going to get ambitious with 2114 and hit enter. And would you look at that? Our statement printed out, a very annoying, very frustrating. We did this to ourselves. We were very ambitious and it didn't pay off. In the end, 2,114 times. So we have, it appears, I'm not going to count it up. I'm not going to count it at all. Oh, shoot. But it appears we have achieved the first piece of that. All right. What was the last thing? The last thing was print out that many copies of the previous message on separate lines. So this is good. Now they're saying go ahead and do this on separate lines. So instead of being all in order, they want us to print this out on new lines. So we can do something like this. Interesting. We can do this in a couple ways. So we need to do a little bit of string concatenation here. So a new line character is it's backslash because it leans backwards. Yes, it's backslash in. So that's the new line character. Now we're gonna run this. This is gonna break. I'm pretty sure this is gonna break. Python 3 turn 100. It's gonna break. Why did it break? It broke because it's basically reading this new line character is a character, so it needs to be put inside of quotes. It needs to be put inside of a string. So I have to concatenate basically this string variable, which is output, with this new line character. Now let me show you something. What happens? So if we make it a string and we go ahead and concatenate it like this, let's see what happens here. So we've concatenated output with new line and we've multiplied it by new num. Let's check this bad boy out. George, 38. Cool, got a number. We're only gonna do 90 because it's a lot. And we hit it, and there's hella white space. There's a lot of white space here. But you can see that instead of this printing out 90 times, it printed out a single time. And then it gave us basically 89. It gave us 90 spaces after that, basically. So why did that happen? That happened because Python follows the order of operations. I know, don't take this personally, but I know that a lot of us struggle with the orders of operations. Notice I didn't say a lot of you, I said a lot of us. That's why all those things go around the internet of like 4 plus 5 times 3 minus 7 or something like that. And it's like, what's the answer? Everyone argues for weeks over what the answer is. And that's because people don't fully understand the order of operations. And so order of operations, think back to grade school, to elementary school, and let's talk about Pemdas. The problem is people do remember Pemdas. People are throwing out Pemdas. People they remember Pemdas, but they don't. They either never interpreted it properly or forgot how to interpret it properly. So Pemdas is parentheses. So evaluating anything in parentheses comes first. That's what the P in Pemdas is. E is exponent. So parentheses first. And parentheses exponents. This is where people get messed up. They say multiplication first and then division. That is not true. It is multiplication or division in order from left to right. So they are equal. Multiplication and division are looked at as equals. And so whichever one comes first, going from left to right, and then addition and subtraction. I like the way that you put it in there, yeasty goodness. But if people don't understand the parentheses, they may not understand that, but it's perfect. Multiplication and division in order from left to right, not multiplication and then division. That is where people usually get super duper messed up. So hopefully that is a little bit helpful. But down here, we have basically the order of operations. Again, multiplication becomes before addition. So multiplication is with the star here. It comes before addition. So we can go ahead now and we can use Pemdas to help us out. So how do you group things together? We can go ahead and put these bad boys in parentheses. And let's go ahead and run this again. So it should evaluate those first. So my name is Earl and I'm 99. So I'm gonna be 100 next year, which is great. Give us a new number, 45. And just like that, it looks like we got about 45 times that my name is Earl, that your name is Earl, and you won't be 100 until next year. And we got about 100 new lines, 100 of these printed out. So that is, we did the entire number one. That took longer than I thought. It took a lot longer than I thought. But we were able to, this is an algorithm. This is the algorithm or an algorithm to solve this problem. It may not be perfect, but it is an algorithm to solve the question that we were asked on whatever site we were on, which I may have gotten off of. So what were we on? We were on practicepython.org, and we were on solution number 1. And so what you can do after you get the solution, this is why I like this site as well. You can take this and you can go ahead and click on, we did all this stuff. And it even tells you what the concepts are. So that you're going to be using. And it kind of walks you through actually how you might be able to use those things. Let's take a look at the solution and see what they have. All right, so looks like they did name. Maybe we can compare. We'll put these side by side in a second. So it looks like they have less code than us. So they've optimized. We never went back to do the last piece, which was optimized. They also do not have the extras in this sample solution. So it looks like they took an input. What is your name? They weren't as kind as us. They didn't say sir or madam. So, definitely I'll be proud of the work that we've done here. Age. They did the same thing. They also agreed that we should cast this to an integer up here. So that's good. That's really nice. We did this up here. And then they use the year, which I'm assuming is the year that this person is now going to be 100. So they did this. They basically did this in line. So it looks like this was done in 2014. They also hard coded 2014 here. And we did this in a separate step. They did this all in one step. We first calculated this, then we calculated the year. So they did it all in one line. Great. We could have done that too during optimization. No big deal, but they calculated this in one line, and they have a print statement. So they actually only have, I think we only have one additional line of code, I believe. So before we changed this into an output, we only had 1, 2, 3, 4, 5, 6. We had 6 lines because we split up the calculation of the years. So there we go. So again, you can see here how this is a lot more optimized, but it is essentially the same thing that we have done. And this is how you learn. You get close or you get the answer and you can go ahead and do this. I think it's weird that they don't have the extras in the solution, because I think that's the stuff that's fun. But cool. That is great. All right, let's take a little break here. And because we took our time and ran through that one, for the second one, take a look at it. Take a look at the odd or even one. I haven't looked at it yet. We should be able to run through this in 30 minutes, no problem. We can run through it a lot faster. We've done all this stuff. I mean, we've already figured out how to break down the problem, read it properly. We can write a bit quick pseudo code. Maybe we can skip the actual breakdown, write the pseudo code real quick, and go ahead and write this code out for this one as well. I think we can get through it pretty fast. But any questions about what we did already? I'll pull our code back up. Actually, let's put this to the left. Excuse me. So that you can see the code, so that you can see the what we're about to work on. And let me move this to the left, and you can't. It's hard to read, but you can see the code here. If you want to copy, if you want to try to copy, I know it's weird right now, but now you can see both at the same time. So yeah, any questions? Scaling, I need to keep it like this just because everything's really big right now so that you all can see it. It bothers me actually. I actually keep my stuff pretty small. It's really annoying. The regex is strong with me. I am real bad at regex. Oh, I see your regex up there. I'm not real bad, but I'm not a good regex writer. I mean, I can figure out my regex with time, but I'm not just someone who can just, oh, here we go. I know how to just write this regex. Regexes aren't, they're not my thing. The thing I always have to go exactly crafted gaming, like for sure. Luckily, we have someone on my team now who's really good at them. So I know I have someone to lean on currently when I need a little bit of help. Regis is like a lightsaber. You have to have a space wizard powers to use it effectively. I agree with that. Yes, for sure. Import date time now, scale limit. Yeah, we could definitely do some local time stuff. So you can absolutely get date and stuff. We're not going to do that because this is later. It's way later than I thought it was. I want to get to like 3 or 4 problems, but we were moving pretty slow there. Well, I won't say slow. I think we were moving at a solid pace to run through that stuff, to really break it down, to take it in, to really understand what we were gonna do. Writing regex isn't too hard. Reading so yeah. Well, so I disagree, because the only reason I disagree is because if someone's already written it, well, okay, no, troubleshooting. Never mind. You said troubleshooting, absolutely. But if someone's regex already works, it's pretty easy to break it down and what it means, because you can Google the characters and like the modifiers and stuff and see what they do, and then it starts to make sense. I actually like working backwards from regexes. They help me understand. I'm definitely going to spend some time though. It's something great to be good at. I think if I could get at it, it would. I don't think it would take long. I really don't think it would take long at all. It would take practice to get great, but I think you could get good in a pretty short amount of time. Probably, I thought I could get good in an hour or two, to be honest, but I don't. Okay, it's 9:31. Let's go ahead and hop into this second problem here. So let's take this. Let's move this down one. Let's full screen it. Let's get out of this code. All right. So what is this one called up here? We got a new one here. We call it even or odd. I like that. I think I know what's going to be already. This may be very fizz buzzy. So if you're watching Fizz Buzz, you watch us do Fizz Buzz, we may be able to leverage a lot of the stuff that we learned there. Maybe. So even odd.py. Paste this bad boy in there. Let's read it through while we still have some color on it before we comment it out. So the algorithm that we have to solve here is we need to ask the user for a number. First part, they're breaking it down for us already. Depending on whether the number is even or odd, print out an appropriate message to the user. Hint. How does an even/odd number react differently when divided by 2? Oh man, they're giving you all the hints. This is good. This is great introductory algorithms. The hints are great. They're powerful. I know some people don't like them. You want to be able to do it all on your own. But again, we're all at different levels here. The hints are great. I like this site a lot. Extras. If the number is a multiple of 4, print out a different message. Ask the user for 2 numbers. All right, we'll get to the extras in a second. So first, we just want to ask the user for a number. Depending on whether the number is even or odd, we want to print out an appropriate message to the user. So now we are adding in, it sounds like we're adding in a little more stuff here. We're doing some control flow. We're figuring out, we're doing some conditional executions, which we just learned about. So we're putting all that stuff in action, and yay modulus. These are, we're adding that in again. This is very reminiscent, not very reminiscent, but these are some of the tools that you just learned with Fizzy Buzzies. All right. Whoa, how did that get? Oh, I was in insert mode already. Just undo. How do I get back to the beginning of the, nope, that's not it. No. Wait, I know this. It's all good. Cool, there we go. So let's go ahead and comment this out. So again, I always have to forget. Down, I escape. All right. Go down, new line. Okay, ask the user. So let's do a little pseudocode. So pseudocode, pseudo code. All right, so we're gonna ask user for number. Ask user for a number. Save to variable called num. Sure, let's do that. All right, ask the user for a number. We know we got to do that. Depending on whether the number is even or odd, print out an appropriate message. So here's where we need to determine if a number is even or odd. How do we do that? How can we determine if a number is even or odd? They gave us a little bit of a hint there. So if a number is even, The easiest way to find out if a number is even is to find out if you can divide 2 into it evenly. 2 is an even number. If you can divide 2 into it evenly, then it is an even number. How can we determine if something goes into something else evenly? That would mean that it would be when you divide it by 2, that the remainder would be 0. So how can we get the remainder? We can use modulo or modulus. We can say something here like divide num by 2, comma, if remainder is 0, comma, print. What do we want to print? We want to print out, it just says appropriate message. The number you have entered is even. It's not Eve, it's even. It's not Eve. The number is even. All right. And so we could do a couple other things with that pseudo code here. We can just say if remainder is not 0, comma, print. The number you have entered is odd. All right, it said print appropriate message. These messages seem appropriate to me. So pretty quick, pretty easy. This one has less steps than the last one. And I think our pseudocode sounds good. We're gonna ask the user for a number. We're gonna save it to a variable called num. We're gonna divide number by 2. If the remainder is 0, we're gonna print out the number you have entered as even. If remainder is not 0, we're gonna print out the number you have entered as odd. Let's go ahead and let's solve this problem. Also, I've seen people say some things about this before. Yes, that is a good one, Lieutenant Hummus. But we're not using. We haven't learned functions yet. Turn X and 1. Yeah, we haven't learned functions yet, so that's why we haven't been using any functions for any of these, and that's why the problems I've been sticking with tonight are ones that can be solved without using functions. I guess theoretically you could solve any problem without using functions, but it would be a lot more work. But yeah, we learn functions really soon, right? I hope. We learn functions. Algorithms tonight, loops, get, then functions. We might flip those. It doesn't really matter. Like, you won't benefit from knowing functions for get, but that's fine. Cool. We're getting there. We're definitely getting there. All right. So let's go ahead. And now that we have our pseudocode, let's get going. Hey, Adozima. Thank you. Welcome to the channel. Thank you for the follow. Are we going to get into decorators at some point? Yes, we will get into decorators at some point. For sure. We're definitely into decorators. It's interesting because when I was building this out, I'm actually worried that the last I'm actually worried that the last 6 weeks is going to be like overwhelming. I feel like the first 6 weeks is a solid pace for a beginner's programming course, and I think the last 6 weeks are going to be as we're kind of getting into projects and things and like just mashing everything together. I think it's going to be a little fast, but I want to make sure that we touch on a lot of different things. But yes, we'll definitely be getting into some decorators. So pseudocode. We got a pseudocode written. Let's start writing this stuff out. So ask the user for a number, save it to a variable called num. So let's go ahead and set up our variable num. What's the URL for the schedule? You can get it at academy.mastermind.io and head over to curriculums. I know now that curriculums is the wrong word for multiple curriculum. Multiple curriculum is curriculae. or curricula. I will get that changed, but it's on there. Head over to curriculums on the left side, and you can see dates as well as topics for both boot camps. This is the Python boot camp. The DevOps one runs on Sundays and Tuesdays. All right. We have our num here. We have a variable called num, and we're going to ask for a number here. And so already, just judging from the last problem, we're going to start learning from our mistakes and learning from our history. So we know that when it says here it's asking for a number, we're going to go ahead and already convert our input to an integer, since we know that our input comes back as a string. So let's go ahead and type our input function. And we say, what are we asking for? Please provide a number. All right. With a space. Whoops, that's wrong. Here. One more for the integer. Cool. So we're gonna get some input here, and we're gonna immediately typecast it to an integer because we need it. We need it to be an integer. So we got our number here. And again, let's go ahead and just for fun, just we want to practice confirming things are right. We also want to practice confirming, we want to practice the tools that are available to us. We want to make sure we know we need it to be a number. Maybe we're solving this. Let's make sure that this is a number. So let's check out type num as well as what num actually is. Excuse me, this LaCroix is messing me up as it does this daily, but I keep drinking it because regular water is just not as exciting. The bubbles wake me up. So we're doing even or odd this time. It's not gonna run, but I want to see what the output's gonna be. And it's not gonna run because why? Starting with line 9, invalid syntax. Let's take a look at line 9. And we'll look at line 9, and you can see here that we have all this pseudo code, which is not real code, and Python has no clue what to do with it. So let's go ahead and do what? Comment it out so that the interpreter can ignore what we have here. Whoops, I just want it here, right? Is this where I want? Yeah. All right. I'm working on being in the pocket of Big Seltzer. I really am. I've become a huge fan of the passion fruit. I have the trusty old lemon here. The passion fruit is a nice change. The problem is lemon goes well with your food. Passion fruit does not go well with your food. So if you just ate or you're eating and you're looking for something to go to pair nicely with a little bit of a fillet of fish or salmon or a burger, lemon is a safe choice. Passion fruit, not so much. Passion fruit is more of the dessert LaCroix. This is for when you're eating gummy bears or you're eating a little bit of chocolate or something. Passion fruit is what you want to pair with that. So I'm not in the pocket of Big Seltzer yet. But I would happily live in that industry. It even says on the bottom here, 0 calories, 0 sweetener, 0 sodium. And apparently that equals innocent. And that is a tagline that I can live by, that I can trust, that I can believe in. So cool. Filet, that's out in French. See, there we go. Ooh, concessions of wine pairing for Captain Crunch. So I don't know much about wine, but I will certainly look for a LaCroix that fits your flavor. That would be interesting. A wine pairing for wine and Captain Crunch actually sounds disgusting, but it also sounds like something that we all need to try. So we may be onto something now. This might be a thing. Captain Crunch and wine. So I don't know if you've ever had. Hold on. There's an alcohol that tastes like Captain Crunch, or it tastes like Cinnamon Toast Crunch. It may go great with Captain Crunch. I forgot what it's called. Let me see. I know someone knows that tastes like Cinnamon Toast Crunch. It's called. This is not what I thought. Oh yeah. Rum chata. Rum chata is what you can just pair it with. So I don't know about a wine, But if you want some alcohol, we can hop on the rum chata train. Rum chata. Look at this. This stuff is good, man. I had this at like I don't know, I think it was like out of town, and they gave me this, and I mean, it's obviously you don't want to drink a lot of it. It just seems kind of weird, and you probably get sick. There's probably tons of sugar in it. But I mean, if you're looking for something to pair with a sugary cereal, the rum chata is exactly what you would like. Wine pairing for Captain Crunch. Riesling. Oh, this is like a thing. Riesling and Captain. Okay. Try that out. Let me know how that is. I'm actually very interested. This all sounds exciting. I like to live my life on the edge and try out things like this as well. So, all right, cool. So now we can run this code. Sorry to get off topic. We're going to get off topic a lot. Please provide a number. I'll provide 40. It is now an integer. We know that we need it to be a number. It is an integer, and it also prints out 40. We're good. We're using the tools that we have available to us to ensure that we're on the right track. We know that we needed a number. We got ourselves a number. So we need to determine if it's even or odd. And we need to, based on whether or not it's even or odd, we need to take specific action. So cool. We can get into, we can do a comparison operator here. And we can use our sweet if statements to do this. So let's say if our number, and we say here, divide num by 2. If the remainder is 0, print this. So we said it here. So we did if num, we said divided by, but we're looking for a remainder. So we're going to use modulus. Modulo 2. How do we determine if this is 0? We're going to check, we're going to use our equality operator. We're going to say if num modulo 2 is equal to 0, go ahead and do whatever we want to do. What do we say do? The number you have entered is even. So we're going to say print the number you have entered is even. All right, cool. Number you entered is even. Let's see if that works so far. So we're looking for a number. Modulo 2 is equal to 0. The number is even. Let's try this out. All right, let's pass in 2. We know the 2 is an even number. We also know that 2 mod 2 is 0. We know the 2 can go into itself evenly a single time with no remainder. And we do that, the number you have entered is even. What about 3? We know that 3 is an odd number and we get no output. That's great. It did not print out. We know that this confirms basically that if we add, let's try one more odd number. We don't get any output. We've confirmed that our conditional, this if statement, only fires. This code down here only fires if this is true, and that should only be true for even numbers. So let's try a couple more even numbers just to make sure we are good to go. We can type in a big number like this, and as long as it ends in an even number, it should be even. So the number that you've entered is even. So we can even use really, really large numbers like that. So we're good to go there, or returns it to us very fast. Cool. Now let's go ahead and let's knock out the second piece of this. So the rest of our pseudocode says if the remainder is not 0, print out the number you have entered as odd. So you can do this in a couple different ways. You could do a whole second if statement. You're more than entitled to do this. And if you did this, I wouldn't knock you for it. But again, we want to make it work first, then we want to optimize. I wouldn't knock you for it. I'm lying. It is odd. But let's go ahead and I just want to show you that this would be a viable solution for this. Let's run this again. We do 2. Oh, never mind. That was dumb. That was real dumb. If I run this, it'll actually never print out this. Okay. We are not checking this. We said to check. We didn't read our pseudocode. I did not follow my pseudocode, and you guys should make me pay for that. I don't know how you would do that, but whenever I don't follow my own instructions. I instructed you to write the pseudocode for you to base your code off of, and I promptly did not follow my own pseudocode. If the remainder is not 0, print the number that you've entered as odd. I went ahead and added in the exact same equality statement. How do we change it to not? How do we change it to the inverse? We go ahead and add this exclamation point here. And now let's try this again. Print this out. 2, the number we have entered is even. Let's enter 3. The number that we have entered is odd. 4, even. 5, odd. 6, even. 7, odd. All right, looking good. You could absolutely do it that way, but there's no need to do it that way. There's no need to do it that way for the biggest reason is that every single number is every single whole number. Well, I think it's every single number, but every single whole number is integer is either even or odd. Those are the only 2 options that we have available to us. So any number that is not even is in fact odd. So we don't even have to do a second comparison. This does take up compute resources. Again, modern computers are super fast. You don't need to worry about that. But again, for optimization and for cleanliness, we no longer need to even do that. If the number is not even, then it has to be odd. So we can use our default case here and say print the number you have entered is odd. And let's go ahead and test out our sweet programs. Also 56, even number, ends in an even number, should be an even number. The number you have entered is even. 57, ends in an odd number, and the number should be odd. The number you have entered is odd. And we could just go like this and put in an even number at the end. It is even. And do it again, just go across, end it with an odd number of 9, and our number is now odd. So our application, our algorithm is complete. And so again, usually you can see here that usually when you think of algorithms, you're probably thinking of this big crazy thing that Google is asking you to do. But this is in fact an algorithm, and we've solved that. So let's see if we can quickly go to the extras. If a number is a multiple of 4, print out a different message. So again, this is getting very fizz buzzy. So we can say, let's start with if it's a multiple of 4, how do we check if something is a multiple of 4? We go ahead and say 4. And again, this is very fizz buzzy as well because it's very fizz buzzy as well because the order of this will also matter unless you add in some extra conditionals that I don't want to add in. So we're gonna say if num module 4, we're gonna say print even, but basically double even because divisible by 4. Let me just for full disclosure, completely 100% full disclosure, there's no such thing as double even. So yeah, no such thing as double even. I love that someone's name is now 82624. Yeah, I like that. All those numbers is that timeout WQ. Let me go ahead and see if is that the output of okay, I wanted to see if your name was the output of one of these that I just stuck in there. But cool, welcome to the channel. Lots of numbers. Appreciate you being here. And then someone followed after. It hasn't updated yet. But when it does, I will see what your name is. So even odd, we can do something like this. Then we've entered is, oh yeah, we could do a some formatting there. Cool. So let's do this to see if our numbers are double even. So is 2 double even? No, 2 is not double even. So let's see. It's even, not double even. Actually, okay, good. This is good. I did exactly what I wanted to do, but I wasn't sure if. All right. So what about 4? 4 is basically basically double even because it's divisible by 4, but it still prints out the number you have entered as even. Let's take a look why. We were only expecting to get 1. and take a look at what we did here. Remember what we said, every if-else statement, every if statement will be evaluated. Every single if statement will be evaluated. Every single if statement that's on the top level, as far as you're concerned right now, will be evaluated. And in here, basically this it looks like it's one continuous block, but it's not. This gets evaluated as one block, and then this gets evaluated as a second block. So anything that's divisible by 4 is also divisible by 2. So you get 2 outputs here. The way that we change that is we change this to else if. We go ahead and give this an else if, and we can go ahead and try this out again. And 2 should give us even, but not the divisible by 4 thing. Great. 3 should give us odd, which it does. 4 should give us basically double even. And we got that, but we did not get even, which is great. So 8 is also a double even. 12 is also a double even. But what about 10? It's just even. Excellent. We've gone ahead and we've solved the first extra piece. And what's the last extra piece? Ask the user for 2 numbers. 1 number to check, call it num, and 1 number to divide by, check. If check divides evenly into num, tell the user. If not, print a different appropriate message. So not much harder, but it sounds like they want us to switch up our whole program. So let's do that. Ask the user for 2 numbers. 1 number to check, call it num. So we're already asking that, num, and then we're gonna add 1 to check. So check equals, same thing, int input, please give us a number to check if the first num is this is a terrible message, evenly divisible by. Very confusing. You wouldn't write this like this. Don't write this like this. If you do, you're a monster. But we're just doing what they say in this extra thing here. They want us to ask for 2 numbers. We got 1 number, we got 2 numbers, and we called it what they said. We called 1 num, we called 1 check. If check divides evenly into num, tell that user. If not, print a different appropriate message. So we can go ahead and change up our stuff here, and we can say if num, I should have left that there, mod check equals 0. Whoa, what's up, fam? Why did that happen? I don't understand. Actually, we're just going to delete all this. Delete. Oh, I know why it happened. It happened because we're missing a extra one of these to close this out. All right, so if num mod check equals 0, we're gonna go ahead and we are gonna print you already knew this went into your number an even amount of time. What a waste of time. This person already knew. They knew these numbers they were put in here already went in here evenly. Yeah, they knew. They just want us to do extra work. And then so we do that. If it goes in evenly, you already knew. Else, same logic here. We need to print out an appropriate message. Print. You also already knew this wouldn't divide evenly. Hello, the great dat git. That looks right to here. Welcome, thank you. Yeah, the great, daft git. Welcome, thank you for the follow. Welcome to the channel. But you knew this wouldn't divide evenly. You also already knew this would not. Would not divide evenly. So very simple, but now they just want us to have, instead of checking if it's even or odd, they want us to use 2 inputs. So let's go ahead and let's run this now. And we're gonna say provide a number 68. and then check if the first number is please give us a number to check if the first is evenly divisible by, even though I have a typo in here, let's say 4. And you already knew, oh, look at that. I did not already know, which means that my input message was wrong. I mean, my output message is wrong. I did not know. I mean, now that I'm looking at it, I knew, but when I just picked a number arbitrarily, I did not know. And I'm proud of myself for that. So now if we do something larger like this, and then we want to check if it's divisible by 43. And yes, you already knew that it's an odd number anyway. It would not divide evenly. So yeah, that is how we have now answered these things here, these even odds here. So hopefully we're right at 10 o'clock. Hopefully tonight, what are the tangible takeaways for tonight? The tangible takeaways for tonight are really simply that algorithms aren't this big scary thing. Algorithms are basically just a set of instructions or a pattern to get to a desired solution, to solve a problem, to basically take input, process it accordingly to provide some output to solve a problem, and that there are simple ways you can go about trying to solve these things. There are some tools that you have available to you. To do so, you can actively comprehend the problem that's being asked to you, because there's probably it's going to be asked in usually a word problem format. But even when you're trying to solve problems at your job, again, you want to comprehend, truly understand the problem, truly understand what's being asked of you. Don't try to make any assumptions until you have taken in everything that's been given to you, and then break the problem down. Break it down into consumable pieces, consumable solvable pieces that you can start working on. Then write some pseudocode. Practice writing some pseudocode to really just get your ideas down, get the flow down, get the logic down on paper without having to worry about the syntax of your code. And then turn that pseudocode into real code, and write your code out and figure that out. And then after you've got it working, take a step back if you have time and go ahead and optimize and make that code a little bit better. And then this slide is also super important. It was to indicate that we were about to practice, but it is an indication to you that you should be practicing these things. I know it's super weird at first. You may hop into a problem and have no idea what to do. Like, you may go on to the next one. Let's make this smaller. It is okay if you go to number 3, and you click on it and you're like, I don't even know where to start. And that's not a problem. Why is that not a problem? Because you have the solution available to you. There is value in working backwards. There is value at looking at the solution, at the sample solution, even though there's not one here. That sucks. But finding a solution or Googling a solution for a problem, other sites, again, like Exorcism, you can see the solutions. It is fine to look at those solutions. It's fine to ask for help and work backwards. Take a look at it, say, oh, okay, I see that you made a list here. I see that you used this .append function, and I don't know what you're appending yet, but I don't know why you're appending something, but I know that will append something to a list. And I can see here that you are looking for the index of an index of an item here. I can see here you're doing a loop. There is value in that, so it is completely okay not to know what to do. The goal is to look at it, to start to get your eyes on these things, to start to see how they're set up. These algorithms, the algorithms to get jobs are basically they're all the same questions. They're not the same questions, but they're a similar format. They're kind of solved in very similar ways using similar tools. So again, we'll dive deeper into that. This was again just the introduction to algorithms. Very simple. We will get into again all the bubble sorting and the merge sorting and the shortest distance stuff and all the fancy things that people want to do with this stuff. We will get into those so that you can solve bigger and better problems. But what really will get you good at this stuff is to practice. And then once you learn some loops and you can do some functions, and you can handle yourself some errors, you'll be able to do a ton of stuff. And then once we get into this object-oriented programming, you're basically a pro, and we can just build all kinds of applications, all kinds of stuff. So you're almost there. We are almost there, almost to where we are going to be great. Let's see. Oh yeah. we're talking about string formatting there. Cool. Stop using Python and prod back around Pi 2.7. What was was Pi 2.7 not like when Pi 2.7 came out? Wasn't Pi 2.7 the last version of 2.2? I don't know. Cool. Sorting algos visualizer. Yeah, I love it. I have a bunch of these queued up. Sorting algorithm things queued up. Oh, what is this? This looks cool. Nice. I like the visualized one. This is nice. Oh, this is valuable. Thank you. This is going in the Google Classroom. All right. This is like mesmerizing, actually. Cool. I hope you guys got something from that. Anyone who's in that's basically it for tonight. Again, if you have any questions about anything, ask away. If you have any more input to provide, for sure provide it. I love this. Again, if you're in the DevOps course, Sunday we're streaming early so that everyone can watch the Super Bowl. We're streaming at noon on Sunday. Other than that, what do I have? Do I have anything else on that? I don't think I have anything. Hey, what's that? Roth618. Thank you for the follow. Welcome to the channel. Who are we rating tonight? Who are we heading over to visit tonight? We're earlier. We're kind of early. Well, we're earlier than the DevOps one. Looks like Teja is still on. Oh, okay. I'll take you guys over to. I will. Oh, he's playing League of Legends though. I wanted to see you guys. I wanted you guys to see someone building what are those things called? A keyboard, but he is playing some games tonight. Let's head over to Coding Garden tonight. Everyone have a good night. Let Coding Garden know we said hi. You can learn a lot from him as well. So definitely do that. Let's see, raid. Or if anyone ever has anyone tech related that you ever want to raid, let me know. I just like to head over to people I know are relatively cool. And like I said, as I find new people, I'll take us over to new people just to say hi. And just to, you never know who can be the next like spark or inspiration to help other people get to whatever level they want to get to. So yeah, let's head over to Coding Garden. We got to count down. 9, 8, 7, 6. Thank you everyone for the great stream tonight. Enjoy your weekend. Go over this stuff and get ready for us diving into some more stuff next week. Let's go.